write something like this, but here is the bag of tricks. So here is that quick way. And remember, you have to follow my steps. In fact, for the first time, just don't do anything. Just follow what I'm doing here. So the quick way is this. It's called the cover-up method. And what does it mean? So number one, I'm going to cover up one factor, x minus 1. So I don't know how to cover this up, but when I say cover up, I'm just going to mark this cover up with a no smoking sign kind of thing. So this is it. It's covered up. It doesn't exist. So once I cover up x minus 1, I am going to solve x minus 1 equals 0. That gives me x equals 1. And plug it in both sides. Plug in both sides. So here we go. So I'm going to cover up this factor. That means this is covered up. It is there, but it doesn't sort of exist. It's covered up. So when I put in x equals 1 both sides, I guess a over 2 times 1 plus 1 equals, sorry, I'm just going to say this. Give me a minute. I'm going to erase this. And when I say cover up, let me write the other one as well. So here we go. I'm trying to get the right color, people. Very good. So here we go. So once I cover up x minus 1, I claim to get the value of b. The numerator of what I covered up. So what about the first fraction? Oh, it doesn't exist. So I'm just going to live with that b equals 5 times 1 plus 1 over 2 times 1 plus 1. That gives me 6 over 3, which is b is 2. Bam, just like that. I'm going to repeat. And then I'm going to give you the math behind it. So I'm going to repeat. When I say repeat, what am I doing? Oh, cover up 2x plus 1. 2x plus 1 equals 0 is x equals negative half. I'm going to plug it both sides. I claim to get the value of a. And here we go. So a equals 5 times negative half plus 1 over negative half minus 1. That gives me negative 5 halves over negative 3 halves. Are we all okay there? I just want a yes, no, something of that sort from you guys. So I'm just going to go back and say that with this mumbo jumbo that I'm trying to show you now, b equals 2. That's all I'm trying to say here. Okay, so I got a couple of yeses, so I'm just going to say this. So this was negative half plus 1. So negative half plus 1, can I write this as 2 over 2? So that gives me negative 3 halves over negative 3 halves. And that gives me a equals 1. So bam, I'm just going to cover up each factor and I'm just going to get that. That's the cover up method. That quickly gets you there. So I'm going to give you a test run with a very, 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 very simple problem. And then I'm going to explain you the math behind it. But that's the trick. So here we go. Let's do this one. So here's the example. Which I can write as 1 over x squared plus 5x plus 6 dx. So far, so good?
Yep.
So Q of x is x squared plus 5x plus 6, which is x plus 2 times x plus 3. So I say to myself, two distinct linear factors. So I'm going to write this as 1 over x squared plus 5x plus 6 is a over x plus 2 plus b over x plus 3. I'm also going to say even beforehand that my answer is already ready. I'm going to say, oh, the integral to this one is going to be a ln x plus 2 plus b ln x plus 3 plus c. I'm going to draw a box around it, and I want everybody to be here with me. So once I found the values of a and b, I'm just going to throw in there, I'm done with the problem. Right?
Yeah, and that.
And now I'm going to run that cover-up method by you, because we have to run it one more time. So here we go. So we are going to cover up x plus 2. I literally want you to use your hands, you know, and this is what I'm trying to say. I'm going to write one more step before we get there. So I'm going to write this as 1 over, and this is what I meant by today I wished we were in that room, equals a over x plus 2 plus b over x plus 3. I don't know how to have that hand here, but this is what I'm trying to say, and just watch this. So I'm going to cover up x plus 2, so this is my cover up. What about this one? Does not exist. So I'm going to write D and E, which means does not exist. And why does it not exist? I'm going to come back and say to you, I'm going to justify, this is mathematically correct, this is not voodoo. And because I covered up x plus 2, I'm going to say, oh, what makes x plus 2 0? Oh, it is negative 2. So I'm going to plug in negative to both sides. So I get 1 over negative 2 plus 3 equals a, which means a equals 1. So far, so good? And I'm going to repeat. So I repeat, which means I cover up x plus 3. And I'm going to do this in blue, so I cover up x plus 3. So that gives me the value of b. And I put in x equals negative 3 on both sides. So I get 1 over negative 3 plus 2 equals b, which means b equals negative 1. And so I go back up there and I claim that the answer to this problem is ln x plus 2. And this is going to be a minus ln x plus 3 plus c.
Professor, I know it's probably easier to do it the way you just did, but it makes our notes kind of confusing, especially if we go back and refer to this later.
And that is why we have to have this way. As I told you, by cover up, I'm literally saying to you that when I'm writing that cover up, that no smoking thing, I want you to place your hand on one of the factors. So DNE current means does not exist. So I want you to really close up x plus 2 on both sides. I literally want you to place your finger on one of the factors and cover it up on both sides. So whatever you cover up,
Professor,
the top is what you get. Go on.
I just meant going back up and erasing the A and B and rewriting it up in the notes above, as opposed to just rewriting it out at the bottom. Because now if I go back and refer to this, it's going to have the final answer, not the A ln x plus 2 plus B ln x plus 3.
I can fix this. So I'm going to put the A back. And I'm just going to write the values up in the front. So I'm going to put A back plus B. Sorry. And I'm just going to say, oh, but A was 1 and B was -1.
Thank you.
Does that help?
Yeah, that'll help.
Yes, Karan, not look at it, but I'm going to show you the math behind it. But before the math behind it, I want to tell you something else, which is literally this. And I'm going to scroll this up. So is this correct? Are the values correct? Let's do them the long way. And what is the long way? The LCD. So if you don't want to write it, don't write it. But this is what I'm trying to say. So what did you have here? 1 over x plus 2 times x plus 3 is a over x plus 2 plus b over x plus 3. By the way, web assign does not have this trick. It will always let you do the long way. So I wanted to run it by you. So the long way then, which is take the LCD. So I took the LCD. So I'm going to get 1 over x plus 2 times x plus 3 is a times x plus 3 plus b times x plus 2 over x plus 2, x plus 3. So now we equate the numerators. So I get 1 equals, and please do this algebra on your own and let me know if this is what you get. This is what you should get. So these are the coefficients of x. And these are the constants. Yes, Joshua, the cover-up methods, you know what, I have this little bag of tricks that I will let you use the cover-up method as far as possible, but there are some instances where you have to go the long way. And we will get there when we get there. But right now, if it is distinct linear factors, cover-up works. Does that answer your question, Jonathan? Great. So I'm just going to say this. So tell me what happens here then. A plus B has to be 0 because there's no x component here, or otherwise I can write this as 0 times x if you want, because there's no x component there. And 3a plus 2b has to be 1. So I'm going to say that b is negative a. I'm just running the algebra by you now. So this becomes 3a minus 2b. Sorry, 2a, because b is negative a equals 1. That gives us a equals 1, which is what you had before. So, which is what you had, which is what you got. This is what cover-up gave you. And because b equals negative a, b equals negative 1, this is what cover-up gave you. So are the constants correct? Yes. So is that mumbo jumbo, that voodoo I'm trying to show you correct? Yes. So I want something from you. Does that work?
I have a question.
Sure.
Anytime that so would I be correct in my assumption that anytime there is 1 in the numerator, you're going to get 1 and -1?
Depends on the factors again, because this time these are, if you notice that for the factors itself there are no coefficients here.
Right.
If I attach some coefficients there, then no, your observation may not work.
Got ya.
Yeah, but right now, yes, if there are no coefficients there, then you can assume, but do not generalize in math, because there are so many permutations and combinations that you could come up with that there's no point in generalizing them.
All right. Thank you.
Okay. So great. Now, so let me explain the math behind it. So math behind the cover-up. Say, this was the situation. So I'm going to write this, and I just want you to understand this. So please, complete attention here. And you don't have to do all this. You don't have to explain all this. I just want you to explain the math, to see you the logic or the math behind the cover up. So here is what I'm saying. When I ask you to cover up, sorry about that. So when I ask you to cover up x plus 2, literally cover up, meaning block this with your fingers. So I'm literally asking you to block this. Wherever you see x plus 2 in the problem, in the denominator, kind of block this. So referring to your bad analogist, Russell, here is one. It's like eclipse. It's like, you know, the moon gets in between the earth and the sun, and there is a shadow. So block this. That's a dark spot. So you are completely going to block this. So I'm going to say this is what I'm using because we are on Zoom right now, which is this is cover up. That's why I'm blocking this. So when I'm blocking this, the math is I'm multiplying throughout each term by x plus 2. And when I'm blocking this, I'm saying that they cancel. So this is what I'm trying to say, that when I say cover up x plus 2, what's going on? I'm multiplying each term by x plus 2. So far, so good? And so x plus 2 cancels here and here. And so I'm left with 1 over x plus 3 equals a plus b times x plus 2 over x plus 3. Right? And then what do I do? So the next move was what? Once you cover up x plus 2, you plug in x equals -2 on both sides. Now, why do you do that? Because this is the only value that will take b away. Because b will be multiplied by 0, and you are left with 1 over -2 plus 3 equals a, and bam, that's the idea of cover up. Questions, people?
Not for me.
Anybody? So I'm just going to pause. I'm going to do a question. I'm going to pause for a question, and then I want to run one by you where I'm going to give you 5 minutes, or not 5 minutes, 5 minutes is a long time, but we're going to work on this together. We're going to use the cover up. So the cover up works for what? For distinct linear factors. As soon as the nature of the factors change, cover up does change.
So we can only use cover up when like it's factorable, like that x squared plus 5x plus 6. Like if it wasn't factorable and we had to use like something like complete the square, we wouldn't be able to use the.
Exactly right. Yeah. So okay. I'm just going to write what you said there. So cover up. See, but these are the different versions of cover up. So let me call it cover up 1.0. Because if you like cover up and you are okay with the tricks, then we will continue with these tricks on Zoom. So this is where you are going to give me the feedback. If this doesn't work, then I'm just going to go a WebAssign way and not teach you any tricks at all.
No, I'd prefer having some tricks.
Okay.
Yeah.
Then let's call it cover up 1.0. So this works for what? Only when you have distinct linear factors, and this rests so much on your algebra. And so when I say distinct linear factors, I'm just going to say this is something like ax plus b times cx plus d. These are our distinct linear factors. Yes, Joshua, the method changes. So let's not try to get ahead of this one. Let's do a problem with the cover-up method. So here's my next example. And I want you to do is this all together.